Hello, the theme of today's video, well, I've been making so many videos today, but the theme of today's video is going to be exponents and what it means. So an exponent is a symbol to describe what we're doing to the numbers, right? So if I have like 5 to the third, what does that third tell us to do? Hopefully y'all know the answer. You guys should have learned this a few years ago. But that 3 tells you how many times we're going to multiply 5 by itself. So 5 to the third means 5 times 5 times 5. That's all that means. And then we can evaluate that. And in this case, that would be 125. Or we could do -3 to the 8th, which would be what? -3 times 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 -3. I wrote it out a lot, but let's get through that. So this will get us an answer. And I'm just going to do this all the time. I'm not going to see if I'm right. But this should be 3, well, it's 3 times 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 3, which should get you 2701. If I'm right, let's see. I know this is 9, and I'm not even going to show you. It doesn't matter. I can just check on my calculator. I'm going to go get one. Does this have a exponent? Not really. I was so wrong. See, that's why you're supposed to have a plan of action. It's 6561. That's why you don't just do things off the top of your head and just assume. All right. And then it's going to be positive because every 2 negatives make a positive, right? So positive, 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 it stays positive, okay? So whenever you're doing that if you ever want to know, is this sign going to be positive or negative, you just count how many negative signs you have, and divide them, and just see if it's even or not. And let's try one more. Let's try -4 to the 5th power. So that's -4 times -4 times -4 times -4 times -4. Mathematically, what does that get us? Let's see. 4 times 4 times 4 times 4 times 4. That gives us 1024, and count the negative signs. Every 2 negative signs cancel out. It stays negative. That's a little intro to them, right? Now, we do this because that's what an exponent is. An exponent is repeated multiplication. Just like multiplication is repeated addition, right? 3 times 2 is just 3 plus 3. But 3 times 8 is 3 plus 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 3. This is repeated multiplication. Now, why is this important? Because it is. But what I'm trying to get you guys to do is you guys got to know the operations of how to use it, and then we'll talk about why to use it. So, let's erase this. Shoot. Look at that, beautiful. Now, if I showed you x to the 5th, you would tell me that is x times x times x times x times x, right? Or if I told you A3B4, you'd tell me that's A times A times A times B times B times B times B, right? Expanding it just means you just go, shoop, you just expand it out. That's it. Now, what I want to talk about now is about when we want to multiply exponents and all that fun stuff. So what I'm going to do is I'm going to write 2 things. I'm going to write x to the 3rd times x to the 4th. So I'm going to break this down into my 2 parts. So if I wanted to expand x to the 3rd, what would I write? X times x times x. And if I wanted to expand x to the 4th, I'd go x times x times x times x. How could I simplify that? Well, don't I just have x times itself how many times? We can count them. 1, 2, 3, 4, 5, 6, 7 times. So this is x to the 7. So we have 2 parts, x to the third times x to the fourth. We expanded it, and we brought it back together. We expanded it, we brought it back together. And we've done that before in other applications of math. Or what if I did a squared times b to the fourth times, I want to write that differently. Let's write that as a4b3 times a6b. Well, let's expand that. I'm going to expand my orange. A times A times A times A, B times B times B. And then I'm going to expand my green. A times A times A times A times A times A times B. Right? If it doesn't tell you, there's a secret one. Now, how many total A's do we have here? When we multiply, how many times do we multiply A by itself? I got 4 over here, I got 6 here, so how many do I have total? A to the 10 times, how many B's do I got total? B to the 4. Now, there's a pattern that's happening here that you might not have noticed, or you might have noticed. Well, we'll see. The pattern is all that we're doing, guys, is to find what this is. Let me put it in different colors. To find what A gets you, we add this guy plus this guy. We add the exponents. And to find what B gets you, we add this guy plus this guy. Right? Or up here, to see what, to get 7, what did we do? We added 3 plus 4. That is the rule of multiplying exponents. If we have some number, let me move this down. If we have some number for multiplying, when multiplying, if we have A to the, if we have x to the A times x to the B, the rule to find however to simplify this is going to be x to the A plus B. We just add the exponents. That's all we do. That's all we do. Right? So if I had, for example, if I had A, B, C, 374 times A, B, C, 9, blank, 3, all we're going to do is we're going to add our exponents. Let's go back to the prettier colors. Well, how many A's do I got? 3 plus 9, which is 12. How many B's I got? 7 plus 1, 8. And how many C's I got? 4 plus 3, which is 7. So when we're adding, when we multiply variables with the same base, so I put the A's together, I got 12 A's. B's together 8, C's together 7. We add the exponents. Hopefully that fits your narrative. Not really your narrative. Let's do one more example. I apologize. I'm going to shut us off, but I got one more example. So, what if I did 5xy times 7 x squared y to the third? We're multiplying, right? Just like we put the x's together when we got to multiply the coefficients too. So we're going to do 5 times 7, which is 35. I know I'm going to have some x's and some y's. How many x's will I have? I have 1 here and 2 there. So I got 3 total. How many y's I got? 1 here, 3 there, 4 total. Deal? And the same thing works when we're multiplying constants. If I have 3 to the 8th times 3 to the 12th, that's going to give us a really big number. That's going to give us a really big number. If I put that in my calculator, bear with me, please. 3 times 3 times 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to get us an answer of 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. That's a really big number. There is an easier way to write that. Can't I just write this as a base with a base of 3? I can just call this 3 to the 20th. Okay? So it even works for constants too. As long as they have the same base, you can play with them. All right? I hope this taught you something, and we can just keep moving on. All right, bye-bye.